So do you want to do the kickoff for the second session of the CLI Symposium? Well, it was a question if you don't want to do the kickoff, but you said yes, go ahead. All right. So welcome everyone for the second session of the CLI Symposium. We are happy that you are here today, and I hope that you have been here also yesterday, which was really interesting talks, and we learned about multiple platforms that we could utilize for the training. Today the theme is slightly different. So we will learn more about the learning scope, and maybe Christian, you want to say a little bit more about the team today?
Yeah, sure. So hi everyone, welcome to day 2. What we have planned is Antti Laaksonen on creating competitive programming material. I think Antti is actually sitting over there, so thank you. And then Gennady Korotkevich on training tips. He has actually sent me a slide finally 40 minutes ago, so thanks a lot for being quite...
I think we all should applaud for sending the slides.
Yeah, let's do that. Yeah. Okay, and then finally we have Andrey, Stankevich, talking about the evolving of training tips from beginners to world champions. And I think that originally it was maybe posted that we'll have it in the D hall, but we changed the location to here because obviously we have a lot more people than we can possibly fit in the D hall. So. Yeah.
All right, so do you want to lead the first talk, and I will take the second one so that we switch?
Absolutely.
Perfect.
Yep. All right, so without further ado, let's have Antti on the session. And the clicker. Yeah, let's go.
Okay, so some background first. So I have been in this field quite long, since 2002. First as student and then as teacher, and I have been both in IO and ICPC sides. And maybe some of you have seen my book or books. So I have written 2 books. First one is an online book, free book. You can download it. And then second one is a published book, not free, you have to buy it. But they are quite similar, so the topic is like introduction to competitive programming and also some more advanced material. Yeah, and then my second contribution, I'm one of the developers of this CSES system. So it's an online chat system, and maybe the most important thing is the CSES problem set. So many people use it for that, and it has a selection of problems. At the moment it has 300 problems, and the final goal is to reach 1,000 problems. It will take some time, but we will add them. And the idea is that they are very basic problems. They have standard techniques, and they are short problem statements. So if you want to learn like basic and some more advanced techniques, you can use this system. I will first talk more about writing books. So actually not many people do that. So not many books are available at the moment. So actually, I would say it's a good situation because if you want to write a book, so you don't have much competition, at least before this talk. So there is room for new writers. And if you have some ideas, some topics that you would have that you would have wanted to read, then you can write a book. And yeah, it takes lots of time. So if you don't have time, so it's maybe not a good idea to write a book. But then it can be fun and rewarding. So it has both sides. It will take long, but then it's also fun and interesting. And actually, before publishing my first book, I thought that it's difficult to find publisher. So I thought if I write a message that I'm somebody from Finland, I have written this book, so that they won't publish it. But actually I did that, and then next day I got a message that they will publish it. So it is not so difficult. And you don't have to be somebody famous or professor or something like that. If you have written a book and it's good enough, then you can publish it, maybe. And also you can learn by writing a book. You have to write so that you have to cover all details and also understand topics very well to write them. And I thought before writing my books that I know some basic concepts well, but then when I wrote the books, then I really understand some things better. So it's a possibility to learn more, also for the writer. Okay, next I will present some ideas for you, so some ideas for books that don't exist, but I think this could be useful. Okay, first idea is a book that has advanced content. So not many people write books, but almost all discuss basic topics, like some introductory topics, including my books. But then there will be good possibilities to discuss some more advanced topics. It's not easy to write such a book because first you have to know some difficult topics, then you have to choose what to discuss in the book, and also explain them clearly. This can be even the most difficult thing, how to explain some difficult things clearly. It's easy to explain easy things, but how to explain difficult things clearly. Then my second idea, it's a bit different book. So my journey to winning IOI or ICPC would be the title. So somebody who is very good could tell something. How did this person learn so well, and what is the history and so on. And I think this kind of book could be very motivating and interesting. And not many people are IOI or ICPC winners, so the number of possible writers is quite small. Okay, then a bit similar book. So somebody who has a long history, who is maybe not a contestant, at least anymore, but it's a coach or teacher, could tell something like what has happened in the field of competitive programming, and maybe present some problems and tell some nice stories about past contests. So also a similar idea about somebody tells their history but from a different perspective. Okay, then here X is some country, maybe typically your home country. So the idea is to tell the history of programming contests in this country. And actually this can be quite important, because if you don't do that, then we can lose some important data. So this is also a different kind of book. It's a historical book, and maybe it's not very very useful for many people if I write a book and then tell something what happened in Finland in 1985. So it's not very interesting for many people, but still it's important historical data, and if you don't do that, then we can lose this data. And also we don't have infinite time to do that, because something that happened like in 1980s or 1970s, so not many people remember it anymore. Okay, and then my last book idea, how to organize contests, like this contest here. So this book would have two main topics. First, how to make problems, and then second topic, how to organize on-site events. And also this topic, it can be difficult to find information, and if somebody does this for the first time, there are many possibilities for doing something not so well. So I think also this book could be interesting to many. Okay, then my second part, website ideas. So this is also for you some ideas what could be done. The first idea is not so unique. So new online chats. Somebody could ask why. So we have lots of them already. But still, the first reason is that it's a good way to learn something if you create as a system. So it can be a good learning experience. And then the second reason, when you want to organize something, it is good that you have a system that you know. If something is broken, you can fix it. If you use some other system, then it may be impossible to do that. Okay, here also exists some country. So this is a bit similar to a book. So the idea is collect the history in national contest in your country. And also in this case, if you don't do that, then it's possible that it will be lost. So it would be good to do that. And I know many countries have a long history. I'm doing this in Finland, and it's even getting some problems from 1990s is difficult, and from older problems is even more difficult. So also in this case, you don't have infinite time, so it's better to do it now than later. Okay, this is one of my favorite websites, the old Usako training system. I used this when I learned many topics. So the idea is do something like that, but like to make a modern website that has modern content. So it would be a well-thought path. It would include teaching material and problems and so on. And I think this was so interesting, at least to me, because it consists of sections, and you have to solve all or at least most problems in a section to move to the next section. So I think this aspect is quite important, and not many systems do that at the moment. If you have all problems available, so it can be a problem that you only select problems that look like nice or easy to implement or something like that. But if you have to solve everything to proceed, so then you can learn better in some situations. Okay, then my last idea. You have seen this page, most of you, I guess, OEIS. So you can if you have some number sequence, you can try to find it using this. So the idea is to do something similar for for problems. So one use case is if you want to find out if somebody has used some problem before. So it would be very nice if you could use this kind of interface and then find it easily. At the moment, it can be very difficult to find. Also, like this page, it could contain some information like scientific papers and how to solve the problem and links to similar problems and so on. Of course, one difficult thing is how to do that, because if you have some number sequence, it's easy to find by giving some first numbers. But then how to do that for problems? At least one idea is that you could give like input and output for some small cases or some canonical cases. Here is one example. You could have, if you want to find the famous collage problem, so you could have this string and give it to the system. So input is 3, and then output would be 3, 10, 5, and so on. And then you would find it. So you don't have to guess something like the problem statement text or something else. You can just give some input and output and then find it. Okay, so this is my last slide. So yeah, I think many possibilities for people who want to do something, and also not many people do something. So if you have some idea, you can do that, and many people can benefit from it. And you can try to identify what is missing and also think what you would like to do. And then this a bit different aspect. So historical data is also important. Maybe not many people need it, but still it's important to collect and make sure that no data will be lost. Thank you.
Oh, you want me to go first? All right, so thank you. I have the pleasure. I think you wanted to handle tourists, right? That's I see. All right, so thank you for the presentation. And I would reach out the audience for questions before you start asking. Just raise your hand. I will try to sprint, or I will try to throw. What do you prefer? Throw or run? Run. All right. So introduce your name and then ask your question.
Thank you so much. My name is Akhtar. I'm very happy to see your simplistic presentation. And you put a lot of thoughts in this simplistic presentation, but I have just one simple question. How do you remove the fearness from the mind of the young learners who want to who aspire to be a good programmer, but they are having a fearful mind? So how can you help them? That's my question. Thank you.
Okay, so could you explain a bit more? So why do they have this problem? So.
Sorry for second round. Thank you. Actually, what happens, the students, when they come, they are actually passionate, they want to be a programmer, but what happens when they join certain sessions, they realize that they don't understand anything. So they develop a kind of a fearful mind, and they get, once they have the fear in the mind, they lose their rest of the aspirations and they end up doing something else in their life. So I want to help them, and I really want your wonderful thoughts in that. Thank you.
Yeah, okay, yeah. So at least one technique that I use is that I tell some stories about myself when I started programming, and I was very bad, and I tried to implement something very simple, but I couldn't do that. But still, even if it was difficult to me, then I could learn it, and then I can be a teacher now. So I think this has been useful for some students, that they see that even teachers have had difficult times for learning things.
Thank you. I see another hand up. So I can introduce yourself and then ask your question.
Hi, I am Anoop. I'm from India. First of all, thank you for the CACS website and the problems and the handbook that you've written. There was last year I was trying to connect to the CACS with the API. I was not able to successfully do that, but does the API work? And if it works, how do you manage the amount of load? Because people can start just, making submissions to your online judge for free. So do you have a plan for that, or does it not work at all? Because there are a lot of API code that I see on GitHub that helps me to connect to CACS.
Yeah. So yeah, it can be a problem if you have too much users, but at least at the moment it's not a problem. So even if you have quite a many users, so we manage, but still let's see what happens if we get more. Yeah.
So technically, I can just build my own website and just use your online judge for free.
Yeah, you can do it, but maybe it's better if you send a message to me first.
Sure.
But
Thanks.
Yeah, but at least at the moment, it's not a problem that we would have too much users.
Cool. Thanks.
Thank you. Any more questions? All right, you make it hard for me, and I will be trying to be a very good audience. So you have mentioned that you would like to have a winner to write a book for a guidance for others, right? Have you been thinking to actually interview them and be the interpreter of their story?
Yeah, it could be a nice idea to do that. At the moment, I'm focusing on writing a book about what has happened in Finland. So maybe it will take some time, but then later it could be a good idea.
No, I don't think later. You have the audience here. Get their name tag and say, "Oh, you are this guy, right? Could I interview you over a Zoom maybe next week after the finals?"
Yeah, that's a good point. Yeah. You can have good connections here. Yeah.
All right. A second question, because I don't see any other hand up. All right. So I will make it difficult for every single one of you. How many women do you have in your contests? Have you been thinking how to engage them in the competitive programming? Maybe we should get some guidance. Maybe it's a great invitation for the next CLI on the next World Finals to actually see how we can engage them more so that we have the gender equity. And I love that you wrote those books, and I love to present more problems for you, and I know you will solve them. Any feedback that you would like to give on gender equity in competitive programming?
Yeah, I think it's like is it so that all speakers here are men this year? Yeah, so it would be very good to have also other people. Yeah. Good
I like
idea.
how you evolved the topic. I was mostly thinking about the contestants, but you are actually already solving the problem. You want to invite the leader on stage, a woman leader, right? So you would like to have someone in the CLI symposium who represents women and who could share the story, how they engage the students, because if we have a woman leader, the woman will typically go and they will try to reproduce the story, right? Thank you. Thank you for your presentation and thank you for the answers.
Hello. All right. So that was the first presentation, and the second presentation will be by Gennady Korotkevich, also known as Tourist. And let me do this. Yeah, does that work? Okay. Cool. Yeah, you can also use a clicker. Oh, wait. Use a clicker.
I mean,
You can go.
can I just do this?
Yeah.
Okay. Oh. I think I'll just stand here.
No, we can take the questions after. All right. So let's give a round of applause for Gennady. Sorry.
Okay. Thank you. Thank you, Antti, also for the nice presentation before me. I think it's important to preserve history and have some training materials. That's awesome. I'm going to be talking about some tips and tricks. And initially, the topic was, well, training tips or something like that. So we are in the ICPC compete track of the CLI. So I'm, mostly known as a competitor. So I guess I'm gonna just talk about some something about competitions. So there is not gonna be any like one big idea in my topic. It's gonna be some compilation of different things that I want to cover. So let's go. We are at the ICPC. As you hopefully know, it's very old and the oldest, I guess, competition and the biggest one in competitive programming world right now. And a lot of people gain like inspiration from it. And so one thing about ICPC is that ICPC rules, as we know them, you have like 5 hours. I guess the total penalty time, like the number of problems is important, then the total penalty time, you have like penalty like of 20 minutes for each submission, something like that. It's like also a very common set of rules. So in general, I mean, I guess many teams or people want to know how to perform well in competitions like ICPC. And there are different ways, so like there are 2 aspects, I would say. One aspect is how you prepare for the competition, like how you learn, how you get like better. And the second aspect is what you actually do during the competition, like what you actually, how do you behave, how do you maximize your result given your like preparation which has been done to this point. So I think I'm mostly going to talk about what to do during the contest and not how to practice before the contest. I think the first topic is also important and you can find materials on it. And the second one, I think I can make it more personal. So, okay, I mean, tips, right? Tips and tricks. So ICPC rules mean that we should solve problems from easiest to hardest. Do people agree with that? Hopefully. Awesome trick. I guess you didn't expect that. But basically, yeah, like you can see in an example that like you want to solve problems from easiest to hardest to maximize your result, probably. So, yeah, I guess I could give some tips like that. But in general, you could also go to some more questionable tips, like for example, this tip, which says don't ever absolve. If a problem appeared at one contest, what is the chance it will appear at another one? So, like on the internet in general, it's very dangerous. It's a very dangerous place, and like you can find some very questionable tips. And sometimes even like very, reputable competitive programmers would post something like that. And you still need to be like, use your critical thinking. And but yeah, I know. I really like what kind of person would actually say that. I don't really know. Okay. Okay. Yeah. So there was a video which we recorded for ICPC Day 0 in 2020 when the World Finals got rescheduled, unfortunately. And there was actually a series of videos, and one of those was tips and tricks from me, but it was a joke, and the tips were like not very trustworthy. But the point also is that you can still get something from it, right? Like if you think about something and like you think about it actually and you realize, okay, I mean, I guess you should just do the opposite, right? If you know, use that thinking, you can still get something from it. For example, I mean, I guess if you say that you shouldn't have solved, then actually you should, right? And yeah, I think in general, like it's useful to upsolve because, like, you know, sometimes you might see some technique that you, like, you know, already know. Maybe. I mean, it's happened sometimes. I guess you also want to read all problems in a contest, because maybe like some harder problems you will not even read, but maybe you actually know how to do them, and then it's good. But there's also like one other technique, one other strategy. You can also write your own problems, and then when you come to a contest, you can see a problem which is familiar to you, but you wrote it, and maybe you haven't even like set it anywhere. So that happened to me several times, I guess. I have some list of problem ideas which I go through, and like sometimes I set contests, as you might know, and to various training camps or code forces, but or ICPC contests as well. I've been a judge at like our regional contest, Northern Eurasia Finals. This year I'm also the first time to judge at this contest, but I'm not going to tell you anything about the problems. Don't you have any hope? But thanks for coming anyway. But yeah, I think talking about writing your own problems, it's actually not that hard, I would say. I know a lot of people who are even like very strong, but they never even considered or like tried setting any problems. But I think it's in general not that hard. You just need to, well, know what the problem looks like and being able to see some like ideas in I don't know, different life situations, I guess. So now, like, if you can do that, you can already be a problem author. I guess if you actually want to like prepare a contest, you also need to have some technical skills. But actually, like, even if you're not into that, you can still write problems and like give ideas to others. So, for example, in our regional contest, I think we are welcoming just some raw ideas, even like from people maybe who don't even know how to solve problems. They just suggest a problem, and you know, maybe like we have judges who actually can turn some idea, some model into a problem. So I think like if you have interest in that, you should not be afraid and just try that out. And also, I would encourage on this topic, I would encourage people to be involved in preparing ICPC and other competitions. Maybe reach out to your local communities and see what you can do to help. And that's actually one of the ways. Talking about the tips from the questionable video, so there is another tip which you can see on the screen. Yeah, okay, if you submit a solution and get an answer, don't worry. Usually it's just a small bug, no need to find it. Just erase your code and write it from scratch again. Yeah, again, I guess you want to look at it the opposite direction, and what you actually want to get from it is that, like, you need to know how to debug your code. You shouldn't just erase your code. And then similar tip was this one. If you get an answer, don't worry. Go to any competitive programming website, open the top-rated list, and send a message to the top 10 users asking for help. So, well, it's not just a random set of words because, well, I guess like on code forces and on average, like I would get like several messages a day usually, and some of them would just be asking like, oh, what's wrong with my code? And I mean, yeah, I guess why spend your own time? But in general, if you want to become better, then you should learn how to debug your code. So, you know, let's go to the next tip. The next tip is about the testing system, and that's the last one, actually. Do you know why testing system is called so? Because its job is to test your solution, so you just submit, just don't, like, no need to test anything local, just submit, it's gonna tell you the verdict, you can just modify, submit again, it's fine. But probably you actually want to learn how to, well, test your code in this case, but I guess my point is like it's important to be kind of, self-sufficient in such things and learn how to do that. So it's more of a tip maybe for people who are beginning, but it's still something that like, it's an important skill to be able to figure out what's wrong with your code and do it quickly, hopefully. But anyway, yeah, I'm not sure exactly how that video, it was about, it was a joke, but maybe not everyone actually understood the joke. Okay, but it's fine. Let's talk about some more tips. Those are going to be a bit serious, but well, I don't know. I guess this slide says focus on your strength and know what you're good at. So I guess it's, again, during the contest, maybe you want to look at problems in topics which like you are good at or which you might think that you have an edge or like you enjoy solving. That's also a good sign. But in fact, like if we're talking about preparation to the contest, that's what we are not talking here. But if we were, then maybe you should actually focus on your weaknesses, right? There are a lot of different ways to think about everything. But I'm just showing some perspectives. If we're talking about ICPC as well, then you also want to know what your teammates are good at. So I think you can you can distribute the problems in the optimal way, and that's also good. So talk to your teammates. That's useful. Use your keyboard because keyboard is the most important resource on the ICPC contest. So, well, you can use it different ways. I mean, you can implement some brute force solutions. I usually call them stupid CPP, and people find it funny. Don't waste keyboard time means that, if the keyboard is nothing, like it's free, maybe you want to use it, for example, to implement some brute force solutions. But also, like, you want to debug on paper. If you can read your code and find bugs, that's also very, a useful skill for ICPC, and we always print out a lot of solutions. Actually, it's interesting. I think a lot of teams that I saw do ICPC at pretty high level. They never used printing out solutions, and well, I think that's a mistake. But maybe I'm joking now as well. So be careful about it and apply critical thinking as always. Yeah, keep track of what you're doing. I think some teams I've seen they just for each contest they would prepare a table on a paper. So a table would be of 3 columns, 1 for each contestant and 1 row for each problem. And then whenever you read the problem, you make some mark in the cell. And if you have some idea, you make some other mark in the cell. And so everyone can look at this table and know what's going on in the contest. So that's one way to do it. But also you can just keep it in your mind for a team. I think for teams which I was part on, I would usually kind of keep the current state of the contest in my mind and try to manage it if possible, but whatever works for you again. Keep track of what others are doing. Yeah, look at the scoreboard, I guess. That's the main idea, what I want to say here. So set realistic goals. I think that is interesting for me. I guess it's mostly about the last hour or something. I don't know, the end of the contest. Basically, you need to know how much time you have left. So at some point, you might need to give up some problems because you don't have time to implement them, for example, or think about them. And also, you need to answer a question like what you're trying to achieve, because sometimes you can be ambitious and try to solve 3 problems in the last hour, or maybe even more, who knows. But maybe sometimes it's better to actually to focus on just 1 or 2 and have better chance to actually get them. For example, there are just some example. I don't know how good you can see it, but hopefully you can. But this is the World Finals 2014, and it was a very hard World Finals. 7 problems was enough to win the contest. and then like silver was 5 problems, so out of 12. It was the hardest ICPC finals ever, maybe, I don't know. But you can also see that the team at the top solved 3 problems in the last hour. So out of their 7 problems, 3 were solved in the last hour, which is pretty impressive. And like you can imagine, like they were trying to solve all of them, especially the last 2, like, you know, in parallel. They were like switching a lot, trying to make submissions, you know, and they had this specific goal in mind that they, I mean, also because they knew they were behind, they needed to solve as many problems as possible, so they were trying to be ambitious and trying to go for as much as possible. But the strategy can also backfire sometimes. This is another example. So this is from the Universal Cup of this season. By the way, Universal Cup, if people don't know, it's a series of team competitions which are of very good quality. It's some regionals, some training camp contests. I would suggest you to take part if you can. So yeah, here you can see that, well, I hope you can see that the team of me, Andrey, and Kevin was trying to solve 3 problems in the last hour, and we couldn't solve any of them. And we lost by 3 problems. So basically, we knew that we would need to solve like 3 because we were behind, but in the end, we didn't get any of them. What else could happen? Like, we could just go for 2 or maybe even 1, and then we would maybe get it. So we would get a better result in the end, right? But we wouldn't have a chance to win, I guess. So yeah, I guess that's how I see it. But I'm like talking a bit more from my perspective. But I think it's like that's at the top level. That's one thing. I guess at other levels there are also similar things. You can still try to decide like what you're going for based on the current state of the scoreboard or anything, and then, you know, adjust your strategy accordingly. Okay. Okay, Code Forces. Hopefully many people here know about this website. And Code Forces rules are kind of similar to ICPC in a way, right? Not really, but also you have like, I think like in Code Forces you also want to solve from easy to hard, the way the scoring system works. Okay, let's talk about this. So this is the last Code Forces round that I did. I guess, yeah, I won by 5 points, which was very lucky. And, you know, if I solve problem D just 2 seconds slower, then I would not win, right? But actually, I guess I just want this as an example that I was trying to strategize even during this contest. So basically, I had some time for, like I had several minutes in the end where I had my solution for problem F already, but I didn't submit it immediately because I didn't need to. Like I knew exactly like when I needed to submit it, so I just spent time reading the solution before submitting. So yeah, I don't know, just some strategy example again. Let's talk about some other contests. AdCoder, well, Yandex Cup and Google Code Jam, unfortunately, is not happening anymore at least, but, well, maybe it comes back someday. So in those competitions, the rules are a bit different, and the penalty time would be not the sum of times of your problems, but it would be like the last time when you improved your score. So I would say it kind of changes the strategy, at least for me. Like you don't have to solve easy problems as fast as possible. You can do it later. You can go from hard. If you can solve hard problems, that's also fine. So 7 years ago, apparently, a long time ago, I wrote some blog posts which describe my strategy at contests like AdCoder. And basically the idea was that I can like go through problems in random order and try to, you know, think about them in parallel, try to like, in my mind somehow, you know, try to switch a lot and hope that when I switch back to a problem, which I was stuck on, I would get some new idea maybe. But I guess also there is a new strategy apparently, which recently surfaced, which I applied successfully or unsuccessfully, the way it depends on how you see it, at Color World Tool Finals, where I only solved one problem out of 5 and got like 8th place. But that's also like, I guess that's an example of like something that I was trying to do, like many problems at once, and in the end I didn't get any of them, almost any of them. And I could go safer and try to solve like problems, like focusing on them more, maybe easier problems, and then get a better place than this one, but that I guess wouldn't give me any winning chances or something like that. I don't know. I'm just saying, I guess, there is no universal strategy. You always need to adjust to what's going on, and yeah, and not everything goes well always. Like, you need to be ready for that, and you know, stay calm and not worry too much about not important things. Okay, there are more competition types. I'm just going to briefly go through them. IOI is the partial scoring. When like you submit a problem, you get some partial scores, and there are subtasks. I mean, it's a whole different story. Meta Hacker Cup is, I guess, similar to IOI. You just get the sum of penalty times, so you want to submit problems as fast as possible and go from easy to hard, probably. By the way, Meta Hacker Cup of this year is going to happen soon, so I also, you know, suggest people to compete. I think even if you don't compete often, that could be an interesting 1 year, or you know, yearly thing, like annual thing that you just do every year. You compete in this just for fun, if you have fun in that, and you know, just brush up a little bit. I don't know. So yeah, there's that. Another set of rules was top quarter, unfortunately not holding competitions anymore, but also it had some interesting like rule that you can open a problem and only then your points for this problem decrease. So, and it required, again, a whole bunch of new strategies, like different, like you can decide which problem to open actually, for example. So it was interesting, and it's a bit unfortunate that we don't have a lot of different rules anymore. But yeah, I mean, it's cool to have different ways to hold programming competitions, even though all of them are, in the end, just solving problems as fast as possible. And there are also like optimization contests, which also require different, I guess, strategies and skills. I think in terms of skills, contests like, okay, at-coder heuristic contests or like top-coder marathons, they would require less knowledge of some algorithms in terms of like, you would probably need to know a couple algorithms like simulated annealing or beam search to be successful, but from there it's like experience and just kind of common sense and thinking about the problem. So it's like, it's a different way of thinking, because you're not solving the precise problem, you're solving some optimization problem. But I think it's also in a very interesting direction, and I guess I would encourage people to try that out. Hashcode and Reply Challenge have been team contests of the same kind, and you're also given the test data. So you could look at the test data and you could strategize based on that. You could distribute different test cases to different people because they would have different patterns, for example. So that's also pretty fun. ICPC Challenge is another team optimization, at least in the recent years, contest. And yeah, I think it's going to happen tomorrow, I suppose. So yeah, good luck, everyone. And I think, I mean, in general, I think it's a nice initiative, and it's good to have contests of this type in general. There are also longer competitions, a couple of them, like ICFPC is like one annual contest which happens, and it's always has different rules. And there's also Code Weekend. It's a competition that was organized by a couple of my friends, Roman and Boris, and myself. They did more. Okay. I mean, I helped, but we organized it for the first time this year. And I think we might look to organize another one. It's like a 48-hour contest, so you're given one problem and you want to optimize your solution and and you have a weekend to make the best, to do the best you can. So yeah, I think we are going to hold another one at some point. So yeah, come participate. That should be fun. Yeah, just to wrap up, I think we can talk about some secret universal advice for all teams. So, you know, to give a secret universal advice, you need to know, you need to have seen a lot, right? You need to know that I know like what can go wrong, what can go right. I have seen a lot of teams prepare. I know what went well for them. I know how to talk to them. And, you know, you need to really have a lot of experience, and you need to be a lifetime coach, I guess. And, well, I'm not that person. So I have no idea. There is no secret universal advice, maybe. But also, maybe, you should tune in to Andrey Stankevich's talk, and maybe he can tell you something about it. So yeah, that's going to be a bit of a cliffhanger, and that's it for me on this presentation. Thank you.
All right. Thanks, Gennady. That was very insightful. Actually, any questions from the audience? Oh yeah. Okay. Let me try to run. I'm a little bit slow. So. All right. A little bit of a maze here. There you go. Yep. There you go.
Okay, earlier on you said know what you're good at. Is it also useful to know what you're not good at? 'Cause they're not quite opposites.
What's that again, sorry? Yeah.
You said know what you're good at.
Okay.
Is it also useful to know what you are not good at, both from preparation and from team building?
Yes, I think I would say, I think during the contest, it's good to know what you're good at. When preparing for the contest, it's good to know what you're bad at so you can rectify those weaknesses. So that's like a difference between your behavior before and during, I think, yeah.
Great. Oh, second. Oh, and when you ask a question, if you can explain who you are first. Wait. Oh, yeah, cool.
So I know that you participate in puzzle contests from time to time. So was it helpful for competitive programming, like for you?
Puzzle contests.
Yes.
I mean, I think it's a good brain exercise, and competitive programming is also can be seen as a brain exercise. So I think they're both helping your brain not to get too old. So that in that way they're useful. Maybe some logical thinking as well, but yeah.
Cool. Next. Oh, wow. There are a lot. Okay.
Oh, wow.
Popular.
In a team competition, what should be the level of collaboration? For example, do you feel that you should be able to debug your teammate's solution or complete parts of the problem together?
So I think it's okay. I think in general, an important thing that I kind of like, realized, and hopefully, I think it's kind of common sense that you're a team, so you just want to work towards a common goal. So I think you should all have kind of, responsibility for each other and understanding what's best for the team. So I think, I would say, like, for example, when we did some team contests, I would normally, let's say I implemented some solution and I get wrong. I don't know what's going on. So I would normally try to find the mistake myself, and I would spend some time on it, but if I cannot, I would ask for help, and like my team members would be happy to help. So you just kind of make the decision based on like the situation. I think that's okay to do that, but it just like it depends on you, like really, like and the current situation. Maybe you want to. Maybe after I submit a problem, I got wrong, but maybe there is another problem I want to go to solve. So maybe I can just give my code to my teammate immediately and go to the next problem. Or there could be some other situation. Just it maybe comes with experience or just some kind of common sense. That's what I see.
Cool. Next one.
Hello, thank you for your presentation today. My name is Grace, I'm an ICPC volunteer. So my question is, among the contests you have done so far, which one do you like the most, like ICPC or AdCoder, Google Code Jam, or IOI, which one do you like the most?
I'm going to be super diplomatic. I'm just going to say I love diversity, and I would really like more different types. So if you want to hold a contest, consider making it unique.
All right, let's give a round of applause for that answer, actually. Yeah. That was a very diplomatic answer. Next one, yeah. Oh, there are a lot, okay. Wow, I have to run quite a lot. There you go, my exercise.
Thank you. I'm a bit excited because I'm talking to tourists. You just got tourist, right? Yeah. Yeah, so my question is a little bit from personal experience and what I saw in our country on the competitive programming community, and it's happening like all the time. And the thing is, like what's next after competitive programming, most people, what they do is they get into some job, and most people like say they are orange color or red, and then get into some job, and it's like very less dopamine work, right? The jobs are like developers, engineers, and I'm talking in mass population, mass amount of competitive programmers. What should be the next step for the competitive programmers to keep the dopamine level in the same? So what do you think about that?
Competitive programming in general gives you a lot of things. I mean, yes, that dopamine level, maybe that's like, you know, constant satisfaction of solving some problems. That's one thing, but also, you know, there's a large community which you might not have got into otherwise, and it's really cool that we can make it happen and make it grow and everything else. So I think in terms of like how to get that level at your job, well, I mean, that's, I guess, very individual. I don't think I have any universal advice. But, okay, let me just keep it here. So, but I think one thing that is what I would want to see more maybe is people staying involved even when they go for a job, if they can still stay in the community in any shape or form. It doesn't even have to be regular, but at least like once in a while. That would be really cool. And also for those people that like could be interesting, so to get at least occasionally get back into this feeling of this atmosphere. So that maybe that could help, you know.
Great. I know that there might be a lot more questions, but to keep the time, let's give a round of applause for Gennady again. I'm sure, Gennady, you can answer some questions at the end, maybe? So, yep.
So thank you. And I would like to invite the third guest speaker that we have today. And I would like to maybe raise a little bit information for those who who are not that familiar with him. So Andrey Stankevich is affiliated with ITMO. I think that maybe it's because of him that the university got renamed. He was a contestant in 2000 and 2001. In 2000 he got silver. In 2001 he got the gold medal. And as a coach, just listen carefully, the numbers are high. World champions in 2004, 2008, 2009, 2012, 2013, 2015, 2017. And he's here again today, guys. Okay. Thank you very much. First of all, I'd like to say that without notifying actually Christian, I decided to change a little bit the topic of my talk, because how can I add to those tips and tricks from Gennady? It's just impossible. His experience in contests is unbeatable, I think. So I would generally talk more about what I said now. It's like which historical options and current options I see as training for ICPC. The idea of shifting, not changing, but shifting this topic to this side came to me actually during IOI about a week ago, when I had a long conversation with two leaders, with the leader of Mexico and the leader of Libya, about how to prepare for programming contests, how to set up a system for preparing for programming contests. So what I will try to describe in my talk is how this system looks like in the biggest country of Northern Eurasia, how it evolved in time, how it changed while I was coaching, and I also took part in building the system, I think. So that's about me, that's about ITMO, that's about ICPC in Russia. So you can see it in slides later. Let's move on to the topic. So the talk plan is First, I will answer the question I was asked most at the last IOI, which is when to start training for contests, no matter for high school students or for university students, when to start. Then I will try to cover opportunities for high school students and for university students. And also, I will give you some universal advice, probably, maybe not. Okay, so let's go on and start with a when to start point. So there are actually multiple opinions on this topic, and the question is quite controversial. So one idea is to start as early as possible. For Russian educational system, it's approximately starting from 5th or maybe to 9th grade. And as far as I know, Gennady, he was from Belarus, he started in, I don't know, 1st grade, 2nd grade. But there are actually rare cases, like top level. And the cons of this situation is that the student whom we are trying to start, who's trying to start early, is actually can sometimes actually get stuck at some point, change subject, go to math or go to kind of robot techniques or whatever. This picture actually shows the counterexample. This is Pavel Mavrin-Pashka teaching Alex Morozov, a 5th-year student of high school, not high at that point, I think, middle school, who eventually got a gold medal at IOI. So now these cases are more and more often actually when kids start early. I feel there are two main reasons for that. One is there are actually very many programmers now who have children of this age. So they start teaching their children. Of course, not all of their children are good in programming also, but they can teach their children at home. So this causes them to know something when they come to camps or training or whatever. That's one thing. Another thing is that now we have compared to times, for example, when tourist was in the 1st or maybe in the 5th grade, we now have lots of camps, extracurricular classes, resources, code forces, or whatever. So Top Coder, for example, used to ban students under 13. Now I think code forces doesn't do that. So students can start early.
However, there are also cons of this, like you say, I know algorithms, but I can't code anything. So we have a lot of students in our summer camps who don't want to listen to lectures, who know everything. They can answer any theoretical question on any algorithm, but they still don't know how to code it, or they know how to code it, but at the Olympiad they cannot. The other thing is that when they start early, they have a lot of time to know each other. So sometimes there is something like what we call camp hopping, when some student visits like 2 or 3 or 4 summer camps, for example. I'm talking about high school students now. And just for the community, that is the good part of this. The building a community is always good, but sometimes it can, maybe he or she can take somebody's place who would not start early, but who would not get experience, who doesn't have enough experience to get to this point. The controversial, another variant is to start late. This is not really the stopper. So what you see, this picture is the world champions of the team of world champions from ITMO, and the person in the middle, Evgeny Kapun, started programming only when he came to the university. So he was on the first year student when he first started programming at all. He used physics. His major was physics in high school. So at the first year he didn't participate because he couldn't even program. At the second year he participated, and the third year he participated and became the world champion. In the fourth year of study, he couldn't qualify to world finals. His team lost. So at the fifth year again, his team couldn't qualify to world finals. His team lost. At the sixth year, he would normally not be able to compete because you can only compete for 5 times. But as you remember, at the first year, he couldn't program. So he didn't participate, so he had 1 attempt left, so he participated again, qualified, and became the world champion, which you can see on the picture. It's never really too late to start. So sometimes people change subject at the university. So now I'll talk a little about opportunities for high school students. So what we have in what do we have? I'm talking from Russian point of view. Of course, you can project that to your own country. So our students could participate in IOI since 1989, and that was also the year that our National Olympiad started. And we also have a team contest for high school students, which started in 2000. And I am the chief judge of that since then. And we also have many opportunities for the students. These marks are given for Russian students, but of course for your students there may be no such limits. It's IOI, and now we also have European Junior Olympiad for those younger students, and the slide 2 steps behind. Girls Olympiad, which I think is very important because even if you look around in this room, you won't see so many girls, like maybe 10%. And that's a pity, actually. And if you look at the contest floor tomorrow, there will be a few girls. And EGOI is just a very good initiative for this. And maybe other super regions would also try to stimulate girls' participation in informatics Olympiads. That would be nice. So Asia Pacific is a nice Olympiad which unites Asia and Pacific countries. And we also have like European regional championships like International Autumn Tournament in Informatics and Romanian Masters. So talking about training camps, here I'm looking at historic perspective. Historically, we had just kind of 2 camps for preparing for IOI, which are summer and winter training camps. In a sense of our government, they are kind of official, so we have 2 official camps, and all others are just people's initiative. And the oldest summer school for high school students we have is Summer Informatics School, which started in 2001. I'm participating in that since 2004. So now, besides that, we have really a lot of different summer and winter schools. Another thing which helped to boost success of our high school students was opening of Serious Education Center, which is the government-funded organization which runs shifts for high school students in math, physics, informatics, biology, chemistry. And most regions also, most regions and big cities also now have local trainings before almost an Olympiad. So it actually evolved during the last 20 years. So this is, the picture shows how the Olympiad in summer informatics school looks like. So the guys are sitting just under trees and solving some problems. The initiative started in Russia. We also had one shift in Ukraine in 2008 and 2 shifts in Estonia in 2018 and 19. And as far as I know, it now has analogous summer schools in Europe, in Spain, as far as I know, and probably in some other countries as well. So this concept of having a school at nature and countryside emerged many other summer schools, which the largest of which are shown on the picture. And it actually had a big shift in knowledge of students. The picture on the right, which I don't know if you can see, if you can discriminate the colors on this, but it shows how the level of students grew during the last years. So this, the same color shows the number, the width of that shows the number of students in the at the corresponding level. So the widest part, which is blue, is level 6 and 7 in our school, which is approximately, I think, code forces like, I don't know, 1,800 to 2,200, like this range of rankings, maybe a little lower, maybe 160 to 2,000, like this. So you see that it started, that even 3 years ago, it was quite a narrow shift, a narrow bar, so, and then it moved on and on and on, and now it is almost 1/3 in the middle. So the lower levels moved away because of other activities, and the higher levels became wider because those students who were at that levels didn't graduate yet, and they went to the next levels. Okay, so the Serious Educational Center, which I have already told about, so it was founded in 2016, and for some reason there was no informatics initially, but after the good results in ICPC, it was added there. So, but the previous activities are usually on-site, but talking about online activities, we have, we have all survived COVID, and now online activities became more usual for us. So we have a couple of big online classes which cover more than, I think, well, a few thousand students. Actually, they're sponsored by big Russian IT corporations, which are Yandex, Tinkoff, and we also have offline training center, for example, an ITMO, and we also have some in other universities as well. So now let's talk about university students. So the oldest camp, for example, which I know was Petrozavodsk training camp, which started in 2000. But then the idea was so productive that many other organizations started to organize their camps. So we had like in Northern Eurasia, we had Izhevsk, we had Moscow workshops camps. We then exported those Moscow workshops camps to other countries. In particular, I participated in organizing camps in Barcelona, in Singapore in, I think, 2018-19. Then there was COVID, and but now new camps, there are new camps. There are camps in Europe, like cli.u.icpc, Cyprus. Huawei is making a lot of camps all around the world, in Moscow, in Europe, I know, in China. Xinhua is making a camp in China. We have local camps in Petrozavodsk again. So the idea of training camps evolved a lot, and now this is the main way for students to compete. So the university camps, I think, give the main boost to the performance of the teams. So there are the main opportunities that these camps give. First, you get out of your, and that is also the reason why I advocate for on-site camps versus online camps. One reason is that you get boost of your productivity and results because you're getting out of your normal life. So you are put into stress of having a contest every day. The second thing is that sharing problem sets, especially between camps and for international camps, gets you out of your problem setter's bubble. I think this is one of the problems that Chinese students had a problem with quite a time ago, when they definitely had good success in the local competitions, as were unbeatable in some online competitions, but at world finals they couldn't compare. So mostly Russian teams were taking the lead. Maybe this was because of the problem sharing at local camps. So another thing, which I think both of previous speakers also mentioned, is that preparing a contest, creating tasks, is one of the best practices you can have for training. So if you want to learn something, try to teach that to somebody, and your progress will be better if you do this. So now, talking about contests, this would a little bit duplicate what tourists have said about Universal Cup or University Cup, Uni Cup is, I think, one of the best series now that most teams planning to succeed at World Finals should actually do participate. There are local contests in Russia and Belarus, best known contests in Northern Eurasia, okay, best known contests now are Ural, All Siberian, and Belarus State University of Informatics and Radio Electronics Open. We also have Federation of Competitive Programming or Sports Programming. Here in Kazakhstan, it is our brilliant host, so thanks for them for hosting this event. In Russia, we also have one, which, for example, introduced competitive programming to Games of the Future contest. And of course, we have lots of regular contests at online platforms, which tourists have covered. So a few words about how trainings are organized at ITMO. The left part of the slide shows how it used to be. So we had like 4 personal trainings in September, followed by team creation. The top teams were usually manually created, but other teams were just like the top student who still doesn't have a team chooses 2. And then we had 2 trainings per week. When Open Cup started, one of those trainings was Open Cup. We almost had no actually data structures and algorithms, especially for these trainings, because our classes covered most of the necessary topics. We only had some maybe extra classes in early 2000, but if your university doesn't have good DSA course, maybe introducing additional classes could benefit your teams. But now the system has evolved, and maybe not to the better side, if you mention to say. So mostly personal trainings are mostly now replaced with online contests like Code Forces or Red Cauda. Team division moved more to free will. It also is influenced by those camps and that I have described when talking about high school. So many students come and already know their future teammates. We try to make one training per week, but as a virtual contest, it's difficult to get everyone together. Now COVID changed this practice, maybe not too good, but we try to have participate in UNICAP, but not regularly yet. I think you should participate in UNICAP, but for most average teams, the problems are too difficult actually at UNICAP. So you only have like 2 or 3 problems solved, and that doesn't motivate. So maybe UNICAP is only for top teams. Well, so that was some brief view of history and current situation in trainings from my point of view. And finally, time has come for a secret universal advice for all teams. And I think that especially for the beginners, especially for the teams at their first stages of trainings, is that many teams tend to concentrate on some secondary things like keyboard time positioning of the keyboard between the students, or who strongest or weakest points of each student. These are all very important things for fine-tuning. But before doing that, I would give the following advice to everyone. Solve problems. Actually, strategy is the secondary thing. It's important to get a better result, but first of all, you need to solve more problems. The more problems you solve, the higher you actually ranked. So that's it for my talk today. Thank you.
All right, thank you for your talk, and we are ready for your questions. Introduce yourself and then ask the question.
Hello, my name is Antti. I'm from Kazakhstan. And there are many cases in Kazakhstan when students can know a lot of algorithms and data structures, even the advanced ones. It is possible that some of them have a high rating on online websites, but during the competitions, especially not Kazakhstan type of contests, they perform badly because they lack some maybe basic or pure logical thinking, and they badly solve the ad hoc problems, constructive problems, greedy problems. So what would you personally recommend to improve?
Yeah, okay. Actually, this is universal advice. Works perfectly for your case. I'm not joking here, because the situation you are describing is very typical, not only for Kazakhstan, I think for many other areas as well. And the solution could be only one. So problems start from the contests of appropriate level and gradually increase difficulty, because yes, the problems, well, we have the same problem actually when we give some algorithm or data structure. We have some educational problems on that topic. They're mostly known well by students, so they have also time for practice, and they also know, since you have a lecture on this data structure, I don't know, segment tree, and then you have this problem, okay, you know that this problem is on a segment tree, so you don't need to find out that. That's why I think that it's very important to practice on real contests of the past. There are now huge amount of contests from the past that you can use for training, and after training, you read solutions or you discuss solutions with a coach or with your teammates or with other teams if you are at the camp. Then you maybe absolve, and after that you go to another contest and another and another, and if you solve a lot of those, then you start to feel and see which algorithm goes for each problem. There is no algorithm to find which algorithm is suitable. This is kind of neural net training, but this neural net is not in your computer, it's in your brain.
Hi, Bob Kramer, East Central North America. You mentioned that in grades 10 and 11, the students don't have enough time to learn all that they may need. But what they do learn, they learn faster.
Yes, absolutely.
Is there a point that balances those two out? Or is there just too much variance in the abilities of various people to say that this is the place where they should start?
Well, first of all, mostly this is almost out of our control. We cannot, I don't know, 7th year student, high school students comes to your classes or comes to your camp. You can, of course, you can say, we only take 10th or 11th grade. If you're a monopolist, if you're not, he will go to another camp just or to another classes. So you cannot tell him, go away. On my point of view, there in both groups of early starting students and late starting students, there are those who succeed and those who are not. And those who succeed in the among later starters are exactly those who are studying faster. That is, yes, the problem which I mentioned, but I don't know the solution actually, is that these very young students, they can easily learn to understand the mathematics behind algorithm, or even don't understand maybe the proof, but they know the idea, and it's not interesting for them to listen to that again or to solve problems specially designed for that algorithm again. So they are in danger of losing interest and moving to other subjects. Yes, that's it. So I would not insist on forcing everyone starting early. If the student wants to start early, okay, we welcome him or her. If the student doesn't want to start early, we would welcome them at the 10th grade or 11th grade, or even at university level. Thank you.
Yeah, Derek Gajewski from University of Arizona. And my question is around getting women into coding practices or contests. Do you see in earlier a propensity to have more women in high school now? Like when I was in school, it was all men and 2 women, but now when I look at school, I see more women. So you talked about earlier, do you see more girls or women in high school competitions than in university? And so the question is, do we start earlier or do we see the same level of splits?
Well, I don't have exact statistics at hand. I would say that probably there are actually more girls participating in high school than at university level, but it is also influenced, in my opinion, by that IT and math and CS is less. There are fewer women in those measures. So since the person, not all of them take part in the competition, so even fewer women are coming to university competitions. Yes, so maybe I'm not sure, but I'm not sure that we should have separate competition for girls at university level, but because the high school competitions have an additional role of bringing girls into computer science and informatics, not only bringing them to competition. So that's
thank you. I'd love to talk more about the statistics and the actual numbers later on. Thank you.
Yeah. Okay. Of course.
All right. So we have the time that reached 9:30. So thank you everyone for joining. I would like to give another round of applause to Andrew.
Thank you.
And please don't hesitate to reach out to them later on. I think that before I let our speakers go, I would like to invite them on the stage. All 3 of you, yes. I was so happy about the last slide we had there before when he said, just solve the problems, right? And now you changed it. Dang.
So if you can fill out the survey so that you can improve it, we'll really appreciate it. So thanks.
All right, so if someone could take their picture, please come on closer. Come here, guys, don't be shy. We are happy to have you here. They are happy that you are here as well. All right, we have some volunteer taking a picture now. Oh, Grace, I thought you were the volunteer. Thank you. Thank you, everyone, for joining. And please know that next year you might be on the stage. So give it a thought of what your speech would be about, and we would be happy with Christian to receive your proposals sooner rather than later. Thank you all.